Hi everybody, welcome back. Hope you guys had a good spring break. I did nothing. I just slept, which was very lovely. I loved it. Anyway, so we're going to go ahead and get into our next unit, which we started in class. So we started quadratics in class and we looked at the basics about what the graph looks like and kind of what's going on there, what the graph can tell us. So today we're actually going to be solving quadratics using the graphs and using factoring. I know it's your favorite thing. So let's go ahead and get into it. So when we're solving, we're looking for solutions. So a solution to a quadratic equation, which we talked about in class, it's just the y equals mx plus b, or no, that's linear, sorry. Y equals ax squared plus bx plus c. That's the one we're going to see the most often. The solution to that would be basically an x value. So we plug in a 0 for the y, and we go ahead and look for the x value when y is 0. So a lot of these equations you're going to see equaling 0. So that's already set up for you. Sometimes you might see a y, sometimes you might see an f of x. Whatever floats your fancy of the day. But most of the stuff that we're going to be dealing with has either a y or a 0 already plugged in. So if you see a y or an f of x or whatever, just go ahead and plug in a 0 for it. So, solutions for a quadratic equation are the values of x when y is equal to 0. Just that. They are also known as roots, zeros, x-intercepts. So any of these words could mean just find the solution. Okay. Again, we already talked about this stuff. A quadratic equation can have 1, 2, or 0 solutions. Just to be aware of, like, when you work it out, you could have 2 answers, you could have 1 answer, you could have no answer. So you got to keep an open mind about it. From a graph. So when we're looking at a graph and we're trying to find solutions, those other words are really going to help us. We're looking for zeros, otherwise known as x-intercepts. Those are the solutions to the quadratic function. Okay? So we look at the graph like, here's an x-intercept, aka 0, here's a 0. Those are 2 solutions. So basically x equals 6 and 8. Done. Those are my answers. Okay? So you guys go ahead and try these 2 on your own, A and B, and when you come back, pause the video, so when you come back, I will have the answers for you. Okay? Good luck. Okay. I don't think this one took you very long. So first one, we're looking for the x-intercepts again. There's only one place. It's at the 1. This is where we only have one solution. So, where'd it go? There it is. X equals 1. Okay? This guy, however, did not cross the x-axis at all, which means there are no zeros, aka no solutions. And that would be our answer. So from a graph, it's really, really nice. And what's even nicer about it is that if you, like, I don't care how you find solutions. Unless they specifically tell you how to find a solution, you can do it any way you like. So by graph, by factoring, even the formula that we're going to do, you can go ahead and do it any way you want. Okay? So, get an equation, plug it into your calculator. I showed you how to find zeros in the calculator, which means you can find solutions using the graphing calculator. Alright, that's page 1. Page 2. Very wordy, I know, but it's just a lot of stuff, just so you know. Solving by factoring. Well, to solve a quadratic equation is to find the x values when the function is equal to 0. The solutions are then called zeros or roots of the equation. To do this, we use the zero product property. And here's what it is. It just says, if the product of 2 expressions is 0, then one or both of the expressions has to equal 0. That's the only way you're going to get something like 2 things being multiplied together that equals 0. One of them has to be 0, or the other one, or both of them have to be 0. So for example, if I had A and B, they're being multiplied together to equal 0, then that means A can equal 0, or B can equal 0, or they can both be 0. Okay? And this is where you're getting the 2 answers. Okay? So if we have this, 10 points if you can name this form. That's right, it's factored form. So this would be just like, instead of standard form where they give you the ax squared and all that stuff, This, they already factored it for you and just gave it to you as two binomials being multiplied together. That's equal to 0. Which is what we want. But once they're like this, we can use the zero product property. So if we have x plus 5 times x plus 2 is equal to 0, then that means either x plus 5 is equal to 0 or x plus 2 is equal to 0. Which then, when we have it separated like that, we can go ahead and solve for x. Yeah, we should be using the word or. Sorry, I forgot. Last page. This should be an or. I should say or. Let me type. It won't let me type. That should be an or. That was fine, that was fine. But it should be an or, not an and. Okay? Oh, now I gotta go back. Clickety click, click, click. You knew it wasn't a Scully video unless I made a mistake somewhere. See? That's just my trademark, guys. So we have x plus 5 is equal to 0. We just solve for x, subtract 5 from both sides. So x can equal negative 5. Or we can go ahead and subtract 2 from both sides. X can equal negative 2. And those would be our answers. So we use this pattern to solve for the variable. We get the quadratic to equal 0, and then factor it. Set each of the binomials equal to 0. So we write two new equations, which we did. And then we solve for the variable. And sometimes you get more than one solution. Sometimes you get no solution. You get no solution, like if you can't factor it at all. Okay? So example here. Example here. We're going to go ahead and start. So it says find the roots, aka the zeros, aka the solutions, aka the x-intercepts. So that's good that we set it equal to 0, because that's what an x-intercept has, y equal to 0. So we'll go ahead and factor this. So we're going to make our magic x, and we're multiplying up to a times c, so that's 1 times negative 30 gives us negative 30, and we need to add up to 7. So what two numbers multiply to negative 30 but add up to positive 7? That would be 10 and negative 3. Once we have that, we can go ahead and write it out as a polynomial, not a trinomial anymore. We get 4 terms, so we have x squared plus 10x minus 3x, because 10x minus 3x will give us the 7x minus 30. Now that we have 4 terms, we can go ahead and group it. So we got this group, and then this group. Once we have 2 groups, now we can go ahead and take the GCF out of both of them. So x squared and 10x have an x in common. Negative 3x and negative 30 have a negative 3 in common. So we take that out. Both of them have the leftovers of x plus 10, which is great because that means I can factor that x plus 10 out. And I get x minus 3 times the x plus 10. And I just made factored form. Hey now. Cool. So now step 2 says to go ahead and take each one of these binomials and set it equal to 0. So we have x minus 3 equals 0, or x plus 10 can equal 0. I made this mistake again. Oh well. So I go ahead and solve for x, so I add 3 to both sides. I subtract 10 from both sides, so I can have x can equal 3, or, it should be or x can equal negative 10. That's easy. That's it. That is it, guys. That is it. Okay? So now you're going to go ahead and try these two on your own. Oh, poo. Oh, well. Okay, I gave it to you. Here is the hint. So this one you had to go ahead and solve. Yeah. Factor it. If you can. Oh. It's a twist. Okay? Try to factor it. And this guy, it's not even set equal to 0. So the first hint would be to make it equal to 0. So you probably have to subtract or add some things to the other side to get there. And when you do, look what happens. I forgot to erase it. You get negative x squared plus 2x minus 1 equals 0. So that's the thing I would factor to figure it out. Okay? Pause the video. When you come back, I will have your answers. Okay. So this first one, you might have figured out. There's a missing term here. You're missing your x term, so you can plug in 0x for it, which means you're multiplying up to 2, but adding up to 0. Nothing multiplies up to 2 and adds up to 0. So this one is actually a prime polynomial, meaning you can't factor it, which means no solution. And if you're smart, you would have checked it in the calculator and graphed it. You would have saw that it did not cross the x-axis, meaning you have no solutions. Okay? This guy, you go ahead and multiply together, so you need something that multiplies up to negative 1. but adds up to 2. Oh, yeah. Multiplies up to 1, but adds up to 2. That would be 1 and 1. And you go ahead and factor it. And once you get your factors, you actually get the factors of x minus 1 and x minus 1. Same ones. X minus 1 times x minus 1 will equal 0. You set those both equal 0, you get x equals 1 or x equals 1. You only need to write it once, so x equals 1. And then if you graph that, you'd see that the... I have no idea if it's a minimum or maximum because I wasn't paying attention. You'd see that the vertex is actually on the x-axis. That is why you only have one solution. That's it. Okay? So if you have any questions, please go ahead and write them down, and I will go over them next class. Okay? See you next time. Bye!